Go. Hi, everybody. My name is Christopher Brown, and this is Introduction to F# Functional Programming for the Rest of Us. So why F#? Well, F# is a very concise language. It takes less code to write the same things as you would in C# or Java or anything else like that. It's an extremely concise language. You write a little bit and you mean a lot. So that's a really, really big selling point, especially when you're writing small, simple things that you should be writing in general. Uh, you can just write more of it and get more done with less code. It's a functional first programming language, but not a functional only programming language. So it kind of straddles the line and you get the best of both worlds. You don't need object oriented programming for all cases. And if you do, you're probably kind of repurposing object oriented programming for things that it doesn't necessarily do. But if you do need, object patterns, then F# solves that perfectly well, and it does good. So one of the things, it's an extremely expressive language. Like you can write it quite quickly and read it quite quickly. And that's one of the things. And then fundamentally, it's a very complete programming language, and it's all .NET all the time. So all the framework stuff, all the .NET Core stuff you can do with F# just like you would with C# or anything else like that. And you can use Entity Framework if you want to. You can use Log4net if you're really interested in old logging frameworks. You can use Seralog. You can use Nathan JSON and stuff like that. Anything that you would normally do in C#, you can absolutely do in F#. So that's a pretty valuable thing. So if you can write less code, write it in a more functional style that's a little easier to test, which is kind of one of those benefits of a functional style, then and do all the same things, I just don't see any reason why you wouldn't want to use F#. But, here's how. So how do you start? You can start with a script. F# also has a script interpreter kind of built into the package. It always has since V1. And the first thing we're going to talk about is just like you would for any sort of hello world sort of scenario, you're going to do hello world in F#. The first thing you've got here is an FSX file, which means the F# scripting language is F# FSX. Sorry, strike that. An F# script is an FSX file. So the first thing we're going to write is printfn hello world. And what that does is the printfn reflects a function call. You do a space in between that and the parameter, the hello world parameter. That's the subject and object. This whole thing is basically this lexically equivalent to console write line hello world, but it's 14 less characters, so we're already more concise, and therefore we've won the battle against C#. Go ahead and convert the entire planet to C#, please. No, not yet. All right, wait a minute. One of the things, so we altogether, when we run it, we get a functional result called a unit. The unit is effectively equivalent to the void type that you would see in C#, except that it's an actual type. C#'s void type isn't a type. It's something that doesn't return anything. But in F# you return a unit type. And that's going to be one of those study little differences, is that F# always returns something. And you have to explicitly deal with the return. In this particular model now, we're saying let result equals printfn hello world. And what we're doing now is actually assigning the value result, or the named item result, to the value unit, which is the result of the printfn function. So the call printfn hello world, it does a hello world write, but it returns a unit. And now it's assigning that unit to the text result. That's a variable, or as in F#, it's more of a value. The let keyword, though, that we just kind of saw there is basically your assignment operator. It gives names to things. So, like, for example, what we have here, let 42 equals the number 42. That's an integer. So if you evaluated that in a REPL, you'd see that 42 is, in fact, an integer. You can also set it's the result of a function, like 49 here is the result of adding 42 and 7. And then you could also name the function itself. This particular function that I'm exempling here will square and add 6 to a parameter called val. And what it does is it takes a val and it multiplies it by itself, which would definition of squaring it, and then adding 6 to the result. Super valuable. But the function name square and add 6 to is now named as a function of the let. So we have now unlocked the let. Yay, we're winning in the learning F#. F# also has tuples. And that's one of the first things that you kind of want to deal with when it comes to F sharp. You deal with your first tuple here with parentheses. So as you see there, you see the let my first tuple. So my first tuple is the name of the thing, and what it'll actually equal out is the values 5 and then 4. And what it results in is a val, which is the reality is all F sharp variables are values, not variables, in the same way. You end up with my first tuple, which is an int times an int. And that times character that you see there is F sharp's way of saying, okay, this is a tuple. And so that's how that works. We can also have tuples that cross type type towards whatever you have. You can have the integer 5 and string that we have here for I'm all about that base. I'm sure that probably should be capitalized in better. I think it's probably a proper noun. I don't know. But you can also deconstruct it by using a comma between two named items there. So you can say the first item, comma, second item, breaks down and deconstructs the tuple. And so in that particular case, if you evaluated what the first item or second item was there, you could actually use that, and then you could create another tuple in that same way. One thing you've got here is that you can also explicitly associate more than just two values. You can use a triple. So you can here, in this case, you can actually suggest, oh, I actually drew a little blue thing in there. I'm going to go ahead and evaluate that, but this particular triple can be broken down into the 3 objects that you see there. Item 1 is reflected to the 5. Item 3 reflects 1.41. And the little blue circle thing that clearly I have drawn in there without really remembering that I did that goes to the list that was indicated there. So tuples are also, equality works exactly as you'd expect it to. So if you have 2 tuples with the same values in them, then you can lexically get those equivalent. And that's pretty valuable. So we've unlocked tuples. So the next thing we're going to try to unlock real quick here is indenting and whitespace. And unlike any other .NET language, whitespace matters here. So for example, in C#, you kind of have whitespace all over the board. And it kind of depends on your preferences, really, what that language and what that whitespace means. In F#, that whitespace matters. Whitespace determines scope. You would think that's kind of gross, right? The initial assessment of that would be, oh my goodness sakes, what do you mean whitespace makes some sort of lexical meaning? But the reality is what that does is it makes all F# look the same. So because you're applying meaning to that spaces and white space, you actually get some sort of value in the white space, as opposed to it just being pretty printing all over the place. And so what that does here in this particular case is it implies that anything in the indented with 4 spaces there implies that are variables or that are within that scope of the function argument, the function there. You can even go double depth here. So for example, your deeply scoped variable here is in the scope of the subfunction object there, and not necessarily of the function argument, right? And you can call that subfunction within that scope, but you can't call it outside of it. All right, whitespace matters. Just get used to that particular semantics. Whitespace has a semantic meaning. It implies scope, as opposed to the structural things of classes and things like that. Whitespace implies scope. So we've unlocked whitespace. The if statement, just like you would branch with every other programming, there's an if you can do there. For example, this is a function called greet, and the first thing it does is it names a variable HR, and it gets the current system date time hour. And then it does a quick function to say, all right, if the hour is less than 12, then we're going to sprintf, which is basically the same thing as a print format or a string format. Good morning S with the name as the second parameter there, and elif and else, which is just your standards that you would expect out of an if statement. But, well, already we unlocked something. But in practice, F# offers match expressions right out of the gate, and it has from day one of its existing. Instead of doing a function based off of an if statement, you actually can structurally plan for a statement that actually deals with matching semantics. So in this case, what we're doing is we're matching the hour with hour, and then there's some guards there to say whether or not the hour is less than 12. We still get that same functionality with the if statement, and we say that you get the arrow that indicates that, all right, if we're going to match an hour that's the hour is less than 12, then we'll arrow into the result of the function, which is printf good morning name. And then if it's less than 17, we'll go good afternoon, and otherwise it's good evening. And notice I didn't have to specify anything else. I just used that underscore parameter to actually say, okay, well, the default case is that. And the match expressions give us some compiler help, right? Because if I don't include that underscore at the end of it, it actually gives me a little bit of help and says, okay, hey, there are some pattern matchings that's, are missing. So that's a very, very valuable feature. So especially, and we'll kind of show it a little bit later about how valuable it really is. But one of the things matching things can do against structure itself. So this is a function that actually returns the length of a list. And what it does is we're going to go ahead and walk through this here. We're going to say that the first thing we have here is the function name is length, and it takes a list, and then it defines another thing called. Now you might see that rec right there. That's actually we'll talk about that in just a second. It defines a function called loop and with a parameter called ack, and then rec indicates that it is a recursive function. And then it does a match against the ack with head and a tail, and then it returns 1 plus the loop, and it keeps going and going. So the first thing it does is actually calls the loop function with the list parameter here, right? And so it takes a list, and then that recursive function goes through there. It will then walk through, and as it defines that recursive function, what it does is it matches whatever it's called ack in this particular case, but list would be just as matching whatever is there. So we're going to match that structure with the head and the tail, and that's actually closer to a standard list or Lispy structure for a linked list. So we get the head of the list and the tail of the list, and the head is the first element in the list, and then the tail is the remainder of it. And what this function does is it says, all right, whatever you have, loop over the remainder of the list, and then just keep going. So in this case, it's going to say 1 for it's going to return 1 plus whatever the result is for all the remaining items of the list, which gets you the entirety of the list itself and the length of it. So what it also does here is if you get fancy, you get some nifty compiler help. So you can say like, okay, in this particular example here, what it's saying is it's going to say, all right, well, if I've only provided one item in a list, well, then return 1. If I return no items in a list, then return 0. But it's telling you, hey, there are incomplete patterns against this. There might be 2 items in a list, and that's compiler help just comes straight out of the box. That is hugely valuable because it lets me get stuff correct the first time. So we've unlocked match expressions. There's lots of looping stuff that we can do. You just like every other sort of programming language in the world, you can loop over things. Like this is a print numbers function. It takes a minimum and maximum, and it iterates over. It says, all right, for all the numbers in there, then print that number. Okay, so what that function clearly does is it's going to say, all right, I'm going to print 1, 2. If you pass in 1 through 5, it'll go through all that iteration, print 1 through 5. And what you can either do for iterating over things is actually create a list with this minimum ... semantics that you have right here. So right now we've got the print number function that takes a float value and prints that float value. And then we have the print numbers, which takes 2 float values and then iterates over that, which is effectively the same sort of thing as like just kind of that for each, but it just takes the list in the first place. This iterates over it. So that iterating item itself, it just says whatever's in the function, the body of the language. List iter just accepts a function with a single value, and you just pass it in. and the list is constructed for the minimum dot dot 0 dot 45 dot dot maximum thing that you can do. You can use pipelining to actually kind of work some similar language semantics, just kind of like you would for like if you were using some sort of bash scripting or things like that, you pipeline things into it. So what we have done here is we've taken the initial list that we're constructing with the minimum and maximum, we're iterating and we're stepping over it with 0.45 as our step, and then we're going to list iter over that and then pass whatever what it does is it says, okay, for each one of these things in this list, this minimum to maximum list is the parameter that gets passed as the last one to the list iter print number. And that's how it works. So it just says take the item on the left of the pipeline and pass it to the last one on the right. And you can continue those on and keep it out. So I'm going to give that list, I'm going to filter it so that in this particular case, that filter also kind of shows you a lambda function there that says, all right, I'm going to filter anything that is evenly divisible by 1, which is probably quite a few less if you're spitting up and going through between, adding 0.45 between two floated values. And we'll filter out anything that is less than, or that is not, or I'm sorry, we're going to filter for anything that is evenly divisible by 1, or in this case, does not have any, doesn't have a decimal part of the number, and then we'll pass the resulted filtered list into the print number function. And so we've done some lists and we've done some pipelines. Nice and easy. Simple types. I love record types. It's so valuable. It's just one of those cool things that F# has that it's kind of akin to a struct, only it's completely read-only. And you might think, well, what would be the value of that? Well, you can more quickly work, with data in sort of as a read-only object. So, for example, this is how you define a simple struct type. It's called a record type, and you just define it, and it basically makes a read-only type directly. So in this case, this is how I would actually instantiate that, or not instantiate, well, I would create an object instance of that type. So in this case, like let CB, that's the name of the object in question, equal, and I don't have to sit there and tell it, hey, it's a person, then the type inference will grab that. I can render a person, and I don't have to tell it that. I just say, all right, whatever the person's first name and last name is, I'll pass to the printfn. And even with some basic, like unlike your C# types, unless you've explicitly defined equality in some sort of crazy way, or implicating the hash codes are the same and all of that sort of stuff, or all of that, or doing the dot equals and overriding that particular function. You don't have to do that. In this particular case, you just kind of get it for free. And that's really, really valuable, especially when you're dealing with data. A type works similar to a tuple, though. So you can kind of get this across the board. Secondarily, you get some deep copy stuff, which is really, really valuable. So instead, say, I'm the dad, my name, and then what my kid would be basically me with a copy with the first name equals kid. They'll still get all the rest of the properties straight up copied over. So that's pretty valuable. And it does a fairly deep object. So just in case, for example, like let's go with my mom here, and we'll add a parent object here, which is actually reflecting the person itself. And we'll go ahead and make it optional. So it's an optional person. So in this case, let's just say my mom has no parents, which is weird, but for the sake of this example, we're just kind of exampling it. And then the copy would be, all right, well, I'm going to make, my name, and we're going to set the parent referencing to my mom. And like my sister, we'll take me and we'll change the name to sis, and it also gets that deep copy of the mom type above it. A word about that option. An optional is basically kind of the treating of null. right? In C Sharp, they're just now getting to the point where not null by default. In F Sharp, it's always been like that. F Sharp deals with nulls if there is something with, as the C Sharp library that if there's some custom C Sharp library that you're using that can consume it, it'll deal with a null. But in practice, you just don't do that. You use the option value, and this lets you deal with that. This item has a value, or this does not. So in this case, there's two values for an option. That you get the none, and which means as indicated there, or you get some, which indicates there is a value. And the difference here is one of those things is that a person is not an option person, right? So where you get some of the craziness of some of the other languages where you expect null by default, in F Sharp, by using the option types, you just don't ever deal with that. You say like, okay, if this is something that can be empty, well, we'll treat it as an option item and just treat the none as a particular object, right? As when you've got the default behavior of certain languages like C Sharp, well, a person can be null, and that's that billion-dollar mistake. So we've unlocked record types and options all in one thing. Unlocked it. Nice. Second things. All right, we're going to keep on moving. We got some union types. We get enums, and enums are kind of a different kind of type. So you can use the basic one just like you would for enums in C Sharp, or where you get basically your list of like allowable values for something, and they kind of are acting the same way. But what you can also do is you can assign properties to those things, and say, for example, a circle is it is a shape, but a circle has a property called radius. A square is a shape that has a property called side length. The closest equivalent in C# is kind of like an abstract base class, and you've added properties to. Whereas this one, like a rectangle, things like this, but it works a lot better, and it kind of handles a ton more cases than you would see in a lot of other things. For example, we can add stuff if it doesn't need a property. Then, like for example, a shape of line doesn't exist, then you get that. But what this really adds, and this is the supercell function of this whole thing, is you get matching semantics, the matching with that particular function right out of the gate. So, for example, I'm going to write an area function, and I'm going to match it against a shape object. I don't have to have like 4 different things. I don't have to have a matching strategy or anything like that. I literally can match it against the object, have one function that's called area that gives you that, and matches it against the circle. In this case, I do have to define the properties that are at, the variables that represent the properties in question. Like in this case, circle has an r, which reflects the radius as indicated there. But square has the side length, so in order to get the area, you just multiply the side lengths together. Rectangle, same thing, long side times short side. But again, that simple pattern matching thing, that is so damn awesome in order to correctly do that. How do you calculate the area of a line? Well, it tells you straight that, like, oh, I've created a line object right to it, and I haven't figured that out as a part of this pattern. Now it's not a compiler error. It's not going to throw something at you. It's just going to say, hey, there's something that you might have done wrong, which is a really, really valuable compiler function. So in this case, the area of a line is 0. But that gives you everything we need. So we've unlocked union types. And there's some other stupid. So assume that I've got a file called somedatafile.csv, and it's got a pile of trades for accounts and whatnot and whatever. What I can do is I can refer to fsharp.data.dll, and I can reference the DLL. And with fsharp, the new stuff, you can actually reference NuGet packages directly. So you'd be just, n NuGet, and then whatever your fsharp package is named. In this case, I believe it's called fsharp.data. But then we create a CSV type provider. We get a sample. And what we can do here is actually go through these particular functions to get the rows and then get the head of it. And then I can actually get just out of the box without having to do anything else. It will actually create a type for me based off of the data files that were there. And you get that straight out of the box. Excuse me. You can give it a JSON source, and you can magically work with the files and the content of that JSON directly. You can do it with XML. You can do it with CSV. You can even point it to a web page and have it point to HTML tables. So go ahead and take a look, see the F# data library. Also, F# data.SQL client, just in case you deal with SQL or Oracle or those kind of things. You can do that directly. Save some time. Type providers, super valuable. You get the types out of the box without having to worry about it. Providers are unlocked. And then let's talk about TDD. What about testing? One of the things that you can do, take a look, see at that function name. I've got an example in a couple of Vex unit tests here, but take a look, see that function name. That looks an awful lot like a requirement. You don't have F# doesn't have the requirement to have a single, no spaces in the name. You can actually have full names for your functions depending on what they are. So in this case, I've named the function quality and sell-in is decreased on normal items. I had to map that into 2 quotes right there, but it does in fact create a function called quality space and sell-in. I've created a couple of objects here that you might have seen the old kata around the quality updating thing out there in the world. I'll link to it somewhere at the end of this video. But at the end of the day here, you've got all of these functions right out of the gate. They read a little cleaner. They do the same thing that you would with any sort of other unit testing library, and you get the same value. And the started quality works just the same. You get all the NUnit, XUnit, MS test stuff works. I'll assume MS test, but if you're using MS test, please consider something else. F# tests are more self-documented because you can write language that is more closely to the language of the requirements itself. And then you get some more tools for the support property-based testing. FCheck or FScheck is an extremely powerful thing that you should probably take a look. See, it's too much for this particular talk, but it's extremely powerful. Also, you have a REPL, so you don't actually have to, as you're writing your test, you can use that REPL with the scripting language to kind of figure stuff out along the way, which is kind of what I do when I'm working with a TDD model of writing the test and then executing it stuff. So some tools you're going to want. If you're going to use Visual Studio Code, which most everybody else is out there in the world, use the Ionide stuff. So that guy Christoph has been, and that whole Ionide team Christoph started it, but that whole team has just been rocking and making a fantastic editor experience, just superb. So you just install those extensions to Visual Studio Code, and you're off and running. As long as you have the F# tools underneath the hood, you're good to go. You can go to fsharp.org to actually get those tools, but you can also do that straight from installing Visual Studio anywhere between 2013 to 2019. You just have to install it with whatever workload that you're actually dealing with. In the 2019, you can see it directly, and I'll show you how to do that. You can actually go to fsharp.org specifically to actually get those tools if you are interested in so doing. Some other stuff that the tools just give you, the F# data, you get to play with that. Swab, it's a simple web hosting tool. F# charting allows you to do quick charts right out of the gate. Fake, which is an awesome language to write build scripts in. If you don't have to. I find YAML a little gross, but and then Packet. Packet is a package manager, just like NuGet, but it's just like NuGet in the fact that it expects you to be aware of dependencies, as opposed to the NuGet package manager that doesn't necessarily force you to be. Here's some resources here: fsharp.org, F# for Fun and Profit. That's not a .com, that's actually a .org, but it'll work for now. Just remember, it's a .org. There's a good wiki book on the F# programming. The Swab.io help. F# data's got a good thing in the F# charting. The language reference itself. Thank you very much for watching. I hope you've enjoyed it. All right, thanks.